All right, so like I said before, we're going to talk about fundamental counting principle. Okay, and the idea for fundamental counting principle, it's taking the total number of outcomes that you have for activity A and multiplying it by the total number of outcomes you have for activity B. So let's write that part down. You take the total number of outcomes for activity A and you're going to multiply it by the total number of outcomes for activity B. Okay, so let's say we're getting ready in the morning. You have 8 shirts, 6 pairs of jeans, 3 pairs of shoes. I want to know how many different outfits can you create. So like I said before, the fundamental counting principle, it's going to just tell you the total number of outcomes in a sample space. It's not going to actually tell you what your sample space is, though. It's not going to say, oh, you've got a purple shirt and a black pair of jeans and, brown shoes. It's not going to tell you that. But it is going to let you know that you have this amount of the total outcomes when given all this situation together. Okay, so all you're doing is you're taking how many shirts you have, which is 8, and you're going to multiply it by the number of jeans you've got, which is 6, and then you're going to multiply that by the number of pairs of shoes you have, which is the 2. Oh, sorry, 3. Oh my goodness, my head is not here today. Thank you. Which is the 3. So what do we get when we multiply 8 times 6 times 3? 144. Thank you. So you have 144 total different outcomes that exist. Now the nice thing is that if you know, oh, I have 2 white shirts and 3, blue shirts and 1 black and 1 red and whatever the details are of it, if you know the details of each of them, then you can find the probability as well without having to make a tree diagram. So let's state that. Let's go ahead and state, okay, hey, of the shirts, we know we've got 2 white shirts. We've got 3 black shirts. And we've got 3 red shirts. Okay, for the jeans, I've got 2 blue jeans. I've got 1 white jeans. 1 black jeans. And we'll say 2 gray jeans. And then for the shoes, I've got 1 flip-flop, 1 sneakers, and 1 dress shoe. Okay? So now I've broken down exactly what I have within those categories. I want the probability that I'm going to choose a white shirt, black jeans, and dress shoes. So again, I know that the total of my shirts is how much? The total of my shirts is how much? 8. I know the total of my shirts was 8, right? And even if I forgot, I can always double check. I can add them together. How many of them are white? 2 out of the 8. Now, I'm not going to simplify yet. Okay. Then I've got the black jeans. How many black jeans? 1, right? 1 pair of black jeans out of the 6 jeans. And then how many dress shoes? 1 out of the 3 dress shoes. And again, I know, hey, if I didn't simplify, if I did not simplify, I know that my denominator is going to be 144. So this comes out to 2 over 144, but then we'd have to simplify it. Once we simplify it, it becomes 1 out of the 72. So you don't have to build a tree diagram in order to be able to do the probability if you know the details. This is the one that gets everybody every single time. I want to know the total number of outcomes from rolling 2 dice. Total number of outcomes from rolling 2 dice. Every year, people say, how much do you think? 12. Every year, they always want to say it's 12. But what is it really? 36. You have to multiply. Fundamental counting principle is a multiplication concept. You have to multiply. So I know that one of the die has 6 outcomes and that the other die has 6 outcomes. And I just have to multiply those outcomes to get 36. And if you were to map it, it would create a 6 by 6 grid. If you were to map it, it would create a 6 by 6 grid where the first die could land on a 1 and the second could land on a 1. Or it could be a 1 and a 2, or a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6, and so on and so forth until you get all the way down to where you have a 6 and a 6. It's 36 different ways that the 2 separate die can land on, okay? Any questions about the fundamental counting principle? All right.